Hello! Well, in this episode of Finno-Grip Machining, we are going to make some caps for slitting saws for this slitting saw holder. Well, I already done two of these. Well, here is one, like that, and another. Well, and these are for different sizes. Let's take the bigger one first. This is a typical staggered teeth slitting saw, and this hole is 32 millimeters. That one here, that portion, is 27 millimeters. And then we have a step there, which then goes like that. Like that. And then that hole goes into that hole like that. And then you have a bolt, normal cap screw, which you put there and tighten it like that. Okay. And then I have a similar cap, so this was for 32 millimeter holes. Then we have one for 27 millimeter holes, and I have a few of these. For example, this is 0.5 millimeter thick and quite large. Well, of course, this bends quite easily. It's still high-speed steel, yeah. And then you can put it like there and use it like that. And then I also have, and this is very special, it has very nice teeth, and this is 27 millimeters. Yeah, and it's really no play at all. No, well, play and play. It doesn't have much room for wiggling. So, but, well, most of my slitting saws are like this. This hole here is 22 millimeters. Okay. So we need to have a cap which has a 22 millimeter part in it, and then, well, then we need bushing actually. So, which is then, the outer diameter is 27 millimeter for the holder hole, and then the inner diameter is 22 millimeters for that, so that it, you can put first your saw into it, and then you put the sleeve, and then you put the whole thing together with a bolt. And yeah, and the material for that one is here. This is 4140. I know. It's pretty hard, and all those were done from this, and we have nothing much left, but this is enough for that one. The bushing can be a little bit softer material. It doesn't need to be as hard as this one. I'm sure I can find something where of which I can do that. This is mainly a lathe job, exclusively lathe job. And we start with the cap. Well, as always, first operation is facing. So I will stumble this into the workpiece, like that. Lock the carriage here. And then I release my compound and take it back a little bit. I will feed the facing I always feed with compound. It's easier that way. So. Okay, now it's totally clean. Next step, this should be turned down to, we need 19 millimeters here, should be turned down to 22 millimeters. And well, let's release the carriage first so that we can do this. So again I reset my compound because it was okay. Lock the compound now, and then I stumble into this one. Zero my travel indicator here, like that, and then I will show you now what I'm doing here. This is the travel indicator. So now when I move the carriage, so it was 19 millimeters we are after here. That's it. Then just lock it. Oh, that was a little bit surprise to me because we had, well, that was actually locked into 19 millimeters already. Be assured that this was an accident. I didn't mean it to be like that. So, yeah, it's 19. Okay. And now when I have this here, that's the carriage lock. Stop, I mean, it stops there. And now when we start here, if we look this, it should stop at 19. Like that. There you are. And then now just put you on good display, and then I'm feeding this now 0.076 millimeters per revolution, and I'm running this too fast at the moment. I try to run it about 500. Yeah, maybe that's maybe a little less actually. So now we have to touch this. That was a very heavy touch. Okay. And then I zero my dial so I can do my advancing. So it will be 1 millimeter cuts. Well, let's take the first. Oh, I need to check that this is traveling in correct direction. Yes, it is traveling, and I will take 1 millimeter out from diameter. So it's half a millimeter per side. There you go. feed on. I want to stop the carriage when it really stops. Okay? And then I feed with the compound until we are touching the surface. Then carriage breed. Whoop. Then I touch the surface. Yeah. And now zero the dial here. We are now making a very faint cut actually. I will slow down the feed to 0.038 millimeters per revolution. Millimeter cast here. And after that I will measure it. And now let's measure that one. It should be 22.75 or somewhere there. Well, it's 22 point. Well, 67. This is a very, very thin cut now. It's exactly 22.5. I'll take this in two cuts, both 0.25 millimeters. And now it should be 22.25. Exactly. Good. 22.25. And now, well, I would like to have it a little bit undersized, maybe 100. Let's see if I can dial in that much. And then just a faint line there. Maybe that. Let's see. Now we have turned this surface and also the backside. They are really, well, the surface finish is, well, you couldn't wish for more. And this is 1/100th of a millimeter undersized. So now, the big question is whether I can slip my slitting saw into there. Well, this is a very good sample. I have had some difficulties with this one because this has a very accurate hole. And it should go, yeah, went there like nothing. Good. And it doesn't have too much play. No. Good. Okay. That's good. Now, well, one step before making the hole here is to make a recess here. This is a little bit delicate operation. I need to go into that corner about, and now I feed in about 0.1 millimeters, about. Let's take a little bit more. There you are. And then I just feed it away from that corner. Wait a minute, like that. Millimeters away. And our 5 millimeters is there. traces there. Okay, it will be just a 10.5 millimeter hole all the way through. Why 10.5? Because there will be an M10 bolt. Well, this is not the 10.5 millimeter drill, this is a stud drill to make the starting point for something. Once I now get it there, there you are. Yeah. And neither is this a 10.5 millimeter drill. This is 4.5 millimeters. It's way easier to drill first with this one and then the rest with well, I think we need some chamfer there. This doesn't need to be very large, just so that you don't hurt your fingers here. That's enough. Okay, this does. Okay. That's enough for that one. For this we need some speed. This is just the bare tongue treatment. Make it shiny and nice. There you are. That's all that is needed. Let's see. This will be really I will be facing quite a lot here. So, and I will be taking 0.5 millimeter cuts. There you are. And the surface, oh, the surface is hot. Oh man. Well, this is now a 13 millimeter drill. This is just to accommodate the boring bar into there later on. I will drill it from that point on 10 millimeters deep, and this is turning about, well about 250 revolutions per minute. And yes, really only 10 millimeters. Presses for the bolt. Nice. That wow. Man. Ah. Now, first, this corner here. That's ready. Okay. Well, I found this short piece of material for the bushing inside this slitting saw holder to take away the room between the 20 and 27 millimeter measures. This will be quite thin walled, so yeah, but this is at the moment 30 millimeters. I already faced it, and now I just, because it's going to, the final dimension will be 27 millimeters, I will peel off 2 millimeters away from it, which should result to 28 millimeters. Then I drill and bore a 20 millimeter hole into there. After that I will fine tune the outer surface to exactly 27 millimeters, make some beautification on the corners here, cut it off, turn around and make the other end beautiful as well. Then we have a bushing. The surface doesn't stop astonishing me. So, yeah, maybe. Wow, it's. Now, if it's also like accurate, so then this is perfect. Well, I couldn't wish for better. It's 1/100th of a millimeter oversize. Well, not too bad. Then and we should be now there. Oh, let's see. How is the surface? Wow. Very nice. Good. The cutting oil did a good job here. Oh, wow. It's good. It's exactly. Well, we are almost through. Should drop any second now. Yeah, it did. Well, now it's going to be test time. So I will now test different types of slitting saws. I have a few of them here. And well, with this new arbor or adapter or whatever that is. Yeah, but first let me set up the milling machine to do the tests. Yeah, the setup is now ready. I will. Well, our first patient is this. It's a solid carbide, 3mm wide slitting saw. And since this has this 22mm hole, we need to use this bushing. There shall be no chips inside there. Because this is really accurate. Yeah, there you are. And now we have this, which is 22mm, and the hole is now 22mm. And well, and these have a very accurate hole. Yeah, there you are. And there you are. And no wiggle. Very good. And then I just put this one on. Tighten the whole thing there. Oh yeah, now let's see. Ooh. Well, this material which I'm trying out here, this is well, it's mild steel, hot rolled, so to say. Let's now first touch it so I know the depth of cut. And it looks really straight. Very soon we will hear whether there is any play. No, I don't mean play, whether it wobbles. When it touches, you can hear it right away. Well, there is some. take it a little bit like that. And how deep do we want to cut this? Well, let's make it 3 millimeters. So 2 turns. Like that. And then I don't know whether this needs any cutting oil. Let's see. Well, I'm running this at the moment, 120 revolutions per minute, and I usually feed these by hand. And so it is now too. And the first cut will make a horrific noise. No, it didn't. Really nice. No trouble at all. Well, it wobbles, but in this case, I don't know where is the wobble originating. No idea. But it's not much. There is your 3 times 3 millimeter groove. Wow. Okay. Now, this one, well, this is a 2.5 millimeter wide, quite large diameter slitting saw, of which traditionally has been chattering like crazy. There you go. Let's see now. Now it's in the bottom. The speed might be too much for this, but let's see. I will put this down to, well, let's see, 4.5 millimeters. But that's the depth it usually starts to, it really chatters. But let's see. So, 3 turns here. 1, 2, 3. Okay, now that's 4.5. And this is not carbide, this is high-speed steel, so we need to use some lubrication here. Now, moment of truth. Works nicely also, and it also is not concentric. I don't know why, really. Wow. It was really nice. I don't know why is it wobbling, but yeah. Okay. Oh well. This is a 3 millimeter radius cutter. Yeah. Let's see now. Okay, there you are. Well, it sounded like good. Like it would not wobble. But let's see. Now, this one I will make a 3mm deep cut with this one. Let's back it up somewhat. So 2 turns. 1, 2. And since this is a high speed tool, needs cutting oil. And now let's see. There is your round groove. Wow. Okay, now we leave the 22mm hole diameter and move to the next, which is 27. Well, this is a 2mm wide staggered teeth cutter, which, I have not been able to use for now, but now let's see. I'm running these all with the same speed, so nothing yet. There you are. It's not. This is definitely more centric. So how much would 12? Well, let's take 1.5, 3. Let's take 4.5mm cut here. And since this again is high-speed steel, we need lubrication. Yeah, definitely more concentric. And this goes like into butter. Well, there is your 2mm groove. And now, this next one is, well, it's a rather large, it's like a CD, and, but it's only 0.5mm thick. It's really thin. Let's touch again. And this is really fast now. There is a and yeah, this is also high-speed steel, so I need to lubricate it. Well, how much? Let's take a very conservative cut, only 1.5mm. I don't want to push my luck with this one. Let's see. Oh, there is your groove. 0.5mm wide. Let's see, did it wander? No, it did not. It's straight. Wow. Let's do this again, but now I will rotate it while I back up. Let's see if it... I want to take a little bit deeper cut and see how it behaves. But this has very fine teeth, so they cannot accumulate much of chips in there. Well, let's see. Well, if I take 3 millimeters, let's see whether it is different. So 1, 2 turns more. Now it's 3 millimeters. Wow. This is really thin blade. It doesn't behave any different. It's no, it's different. Yeah. This tries to do recutting. So you have to be really careful with this one. Very slow feed. But again, this doesn't vibrate. I don't want to cut anymore. This is, yeah, okay. You can cut deep cuts with this one. Okay. Like several times the diameter, the thickness of the blade. Okay, that's one. Yeah. Well, as a last but not least is this. This is, well, it's not last but last for this whole diameter. This is 90-degree groove cutter. This is pretty fast also for this one, I believe. But there you are. Well, it's how deep? Again. Well, I don't want to push my luck also here. So let's take, because I'm not familiar with this one. So 3 millimeters. So 1, 2 turns. Okay, and since this is a high-speed steel tool, we need some cutting oil there. And let's see now. And it cuts really nicely. There is your V-groove. Wow. And again, it's wow. Very nice looking, actually. I will take some photos of this, but this is okay. Well, as a last test, we will do this. This is 4.5 millimeter wide staggered tooth cutter with 32 millimeter diameter in the center hole. So let's see now. There it should be. There you are. So this is, well, looks wider than 4.5 millimeters, but yeah, let's see now. So how much this time? Let's take 4.5 millimeters, so 3 turns from this handle. 1, 2, 3. So it will be 4.5 times 4.5. And again high speed steel tool, so cutting oil is a must. And this will make a horrific sound first. Well, not that horrible. I can tell it cuts like butter. Well, there is a groove. Again. Okay, let's see now. Well, hopefully this focuses. Okay, that one there was the first groove we made. Actually, the 2 first ones, and well, it was behaving, well, some wobbliness, and it behaved. And then we made, for the same diameter, we made this round groove here. And well, it became amazingly easily, if you think about this. There was quite a lot of material removal here. And then we moved to the bigger diameter of center holes, and then, if I recall right, this was the next one. It was a staggered teeth cutter, and it was really easy. This is, I think, 4 millimeters deep, and there was no trouble at all. And then this is the 0.5 millimeter. 0.5 millimeter cut here. There is a 0.5 millimeter groove. Then we also made this V groove here, and it turned out to be quite nice. And then we moved to the bigger guy, the biggest diameter of the hole, and it was this. This is the last one, and well, the finish here is gorgeous, really. It doesn't, this is 4.5 millimeters deep and 4.5 millimeters wide. And it was really quick operation, and it became, I can tell that the sides are straight and the groove itself is straight. Yeah. So, all in all, this tool, I think this is now okay. We succeeded with this one, certainly. And you know, it's very hot here in my shop. For some reason I have 27 degrees Celsius here inside, and that's hot for me. I know that most southern guys can tolerate like 5 degrees more even, but I cannot. So, okay, but this concludes this episode of Finno-Ugric Machining. In the next one, let's see what pops up. Till then, bye!